Hey, y'all, let's cover lesson 38, graphing linear equations. This is the last lesson for this module and this semester. You've made it. So the equation y equals x plus 1 is called an equation in two variables. And the variables are x and y. So that's why there's two of them. If we substitute the ordered pair x, y, and make it equal to 1, 2 into the equation, do we get a true statement? So here's how I'm going to tell you to do this. I'm going to line up my x and y and my 1 and 2. Where my x is, I'm going to put 1. This is just substitution is all it is. Where my y is, I'm going to put 2. And I'm going to just verify if they are equal. So using the equation, y plus, Lord, y equals x plus 1. Why not start this way? This is fun. All right, so y is 2. Not about me. Y is 2. So y is 2. I just substituted it. Equals x is 1 plus 1. So all I did was substitute. And then I just need to work my right side. That's the only thing that needs to be done. 1 plus 1 is 2. 2 does equal 2. So yes, it is a true statement. Yeah, this is a true statement. Okay. So what that means is the ordered pair 1, 2. This means that 1, 2 is a solution of y equals x plus 1. That's what this means. If substituting the ordered pair x, y, and ab into an equation, you're going to replace the x with a, and you're going to replace the y with b. This is just what we did up here. If this is confusing, where the x and the y are, leave them. But where the a and the b are, put 1 and 2 so that you can see what we did up here. We replaced the x. We replaced that x with the 1. We replaced that y with the 2 because these are in the situation, the order of x, y, so therefore x and y. I think I've beaten this up. So produces a true statement, and then the ordered pair of AB is called a solution of the equation and is said to satisfy the equation. Which of the ordered pairs are solutions of the equation? So the equation is y equals 2x plus 5. So y equals 2x plus 5. What might make this easier for you is to leave a space equal to space plus 5. So where that y is, you're going to go over here and put, well, these are in xy form. This one's an xy as well. You're going to plug in the -2 where the y is. And you're going to plug in the -3 where the x is. Now we're just going to bring these straight down. -2 is equal to 2 times -3, just doing order of operations, is -6 plus 5. -2 equals -6 plus 5. The signs are different, so we subtract and take the sign of the larger number. -2 doesn't equal -1. So no, not a solution. So that means that -3, -2 is not a solution of the equation y equals 2x plus 5. Well, I want you to pause the video and do this next one yourself. Y equals 2x plus 5, where the y is, substitute the y, where the x is, substitute the x. Bring down the left side, solve the right side, bring it down, see if they equal. Pause the video and then come back to see how I did it so you can see if you were right. All right, so where the y is, I'm going to plug in 15. And then it's 2 times where the x is, I'm going to plug in 5. So I have to just bring this 15 down. 2 times 5 is 10 plus 5. 15 is equal to 10 plus 5 is 15. So yes, 515 is a solution to the equation. Okay. All right. The graph of an equation is the set of all ordered pairs that are solutions of the equation. All right, in the equation y equals 2x plus 5, the value of the variable y depends on the value of the variable x. And that's why we call the y the dependent variable and x the independent variable. So y is the dependent variable because it depends on what x is, and x is the independent one. Independent. There. We're free to make choices for x, but the value for y is completely dependent upon what the choice is for x. All right, it's dependent. So we will assign, we're going to assign the horizontal axis for the independent variable x. And that's the one that goes horizontally. And then we're going to the vertical axis for the dependent variable y, which is why I was using that in our last lecture. The graph of y equals 2x plus 5 consists of all ordered pairs that are solutions of the equation y equals 2x plus 5. Our task is to first find ordered pairs that are solutions of y equals 2x plus 5. And then we're going to plot all those solutions and connect the dots to form the graph. All right. So I'll show you. I'll show you. It's a lot of words, but I'll show you. There's different ways to find these solutions. But the most straightforward is to choose arbitrary values for x. So we're going to substitute. We're going to substitute them into the equation, just like we did up there, and calculate the corresponding values for y. So instead of just bringing them down, we're bringing the y down, but we're solving everything on the right so we can see what y ends up being based on what x is. I'll show you. We will choose integers from -7 to 2 to find solutions. Nope, that one. All right. We're going to complete the following table. All right, y equals 2x plus 5. That's the equation. We're going to let -7 be x. So y just stays where it's at. So we're going to have y equals 2 times -7 plus 5. So I'm going to set this all up just like that. The next one will be y equals 2 times -6 plus 5. I'm just substituting the -5 in next. Y equals 2 times -5 plus 5. All right, I'm going to pause this while I do this, and then I'll come right back. You could please continue until you get all the way down to the 2, and then I'll come back and show you what we're doing next. Okay. If you got confused, please pause the video and go through and fill out the rest of your form, or at least do a couple and then try to do the rest yourself, because you're going to have to be able to do this. All right, we're going to do order of operations. We're going to multiply, and then we're going to add the 5 for all of these. 2 times -7 is -14 plus 5. I'm just going to keep going with this. And that's equal to 9, -9. So when x is -7, I'm going to come over here and put -9. And that creates the ordered pair -7, -9. Once we get through with all of these, we're going to come down here and plot those ordered pairs so you can see what it looks like. All right. So I'm going to do whatever it takes for you to pause the video and attempt to do the next one yourself. When you're done with this next one, come back, see how you did. If you did it great, then go through and do the rest of them and fill it out the rest of the way. Let me show you how to do this one as well. 2 times -6 is -12 plus 5, and that's -7. So that's going to be -6, -7. the video, go and do this yourself. And then come back and see how I did the rest to make sure that you're on par. Okay. 2 times -5 is -10 plus 5 is -5. So this is going to be -5, -5. Cool. Favorite number. -4 is next. So 2 times -4 is -8 plus 5. And that's -3. So we've got -4, comma, sorry, -3. All right. It's going to be -3. I just want to do this so I don't mess up again. I've seen me do it. All right. So the next one is 2 times -3 is -6 plus 5 is -1. 2 times -2 is -4 plus 5 is 1. -2, I'm sorry, 2 times -1 is -2 plus 5 is 3. 2 times 0 is 0 plus 5 is 5. 2 times 1 is 2 plus 5 is 7. And then 2 times 2 is 4 plus 5 is 9. All righty. Woo! That was fun. All right, let's take each of these ordered pairs and plot them. I'm going to do a couple. I'm going to do like the top one and the bottom one because I want you to see how it moves again. And then I want you to go through and attempt to do the rest of them yourself. Maybe do 1 or 2 to see how you did and then finish them up. I want you to get the practice in this. So I'm going to start with the -7, -9. Coming down here, I'm going to plot -7, -9. The -7 is for my horizontal axis, starting at the origin, okay? And so I'm going to go -7, 1, 2, 3, 4, 5, 6, 7. Do not put a point there. That's just a placeholder. And now we're going to go up to 9. Just be right here. Oh, is it negative? Oh, well, hell no. Of course it wouldn't be. Sorry, y'all. I'm going to write this down. -7, -9. It's been a long day of videos. Go back to our -7, but it's -9, so we have to go down. Hopefully y'all caught that and didn't make my mistake. There we go. -7, -9. I'm going to label that. All right, let's do the bottom one here. 2, 9. I can't really miss that one too much. We're going to go to the right 2 because it's positive, and then we're going to go up 9. Place your point. That's 2, 9. I'm going to go -1 and 3, just to check mark that we've done these. -1, 3 was going to be to the left 1, because it's -1, and then we're going to go up 3, so it's positive. All right, pause the video, go through, put the rest of them in, and so that you can practice. If you see that they're not creating a line and you get something crazy like I did over here, just know that it's going to be wrong. You need to come back and see what happened, and then you can keep trying the rest of them. You'll have plenty of practice on this on your homework, hopefully. All right, so pause the video, go do that yourself, and I'm going to keep plugging away on this. I'm going to start up here at the top, -6, -7, which means we're going to go left 6, and then we're going to go down 7. Right there. The next one was -5, -5. So left 5 and then down 5. Right there. Negative. -4, -3. So left 4, down 3. Right there. Yep, it's up. There it goes. -3, -1. 1, 2, 3, 1. 0, 5. I did that one. Did -1, -3, -2, -1. -2, 1. There it is. I'm missing anyone else? No, there we go. Now it's 0, 5. 0, 5. And 1, 7. And then we already did 2, 9. So it looks like I might have missed some in there, but you should see a straight line. That's probably the straightest line I've ever made in my life. With all the points that we just plotted. I didn't label them all I did cover them as I went through. Please make sure that it looks like actually 1, 2, 1, 2, 3. Yeah, no, looks like they're there. If you have any questions with this, please let me know. Okay. So find the value of K so that the point 2K is on the graph of the equation y equals 3x minus 2. So y equals 3x minus 2. So on the graph, if it is on this line, which is what they're calling the graph, if it's on the line on the graph, then that means it is a solution. It is a solution. Okay, it has to be on the line that we just plotted. So we want to find, instead of y, we're going to use, where's it at? 2k. So 2 is your x in this value. And k is our y, and we're going to solve for k. So k is equal to 3 times 2, which is 6, minus 2, and k is equal to 4. All right, so that means the point 2, 4 is going to be a solution. So 1, 2. Oh, no, it's not. What is that? Hold on, let me look at this real quick. Oh, it's not on this graph. This is a different graph. Oh yeah, this is 2x plus 5. That doesn't even make sense at all. This one's 3x minus 2. So that means you can have a line. The line is y equals 3x minus 2. 2, 4 has to be on that graph because that's what we got. All right, as 2 is our x. Lord have mercy. Okay, a few more, guys. We will get there. So we're going to sketch the graph of y equals negative 2x plus 1, and we're going to create a table of solutions. All right. There's a specific way I do this. I only use 3 points because 2, if you only use 2 points, you can mess it up like I did in that last one. But if you use 3 points, there's a less of a chance of you messing up the graph. So we're going to only use 3 points for this one and 3 points for this one, even though it's not a fraction. I'm going to show you an easy way to do it to get rid of that fraction so that we don't have to look at that nasty little critter. All right, so if we've got y equals negative 2x plus 1. I'm going to set up that basically that same little chart that we had earlier. I'm just going to leave it. I'm going to make this our ordered pair right here. All right, so this is our x. This is our ordered pair that we're going to plot. And I only need 3 numbers. I always use negative 1, 0, and 1. All I need to do when I don't have a fraction next to my x. If it's just like this and there's no fraction next to your x, then you're going to want to use negative 1, 0, and 1. And I'll show you why they're the easiest to deal with. Y equals negative 2 times 1, negative 1 plus 1. Negative 2 times negative 1 is just 2. Plus 1 is 3. So our ordered pair is negative 1 and 3. There's our first one. 0 is even easier. That's y equals negative 2 times 0 plus 1. Negative 2 times 0 is just 0. Plus 1 is 1. So 0, 1 is our next ordered pair. All right. The last one I use is 1. And that's y equals negative 2 times 1 plus 1 is negative 2 plus 1, which is negative 1. So 1, negative 1 is my last one. All right, I'm going to plot these. Pause the video, you plot them first, and then come back to see if yours looks like mine. All right, negative 1, 3, negative 1, and then it's positive 3. So right there. The next one's 0, 1. 0, 1 is right here. 1, negative 1. So I need to go right 1 and then down 1. And that is 1, negative 1. So let me draw this line the best I can here. It keeps going in both directions forever and ever. And that is the line y equals negative 2x plus 1. All right. So the graph of y equals mx plus b is where M and B are constants. And they'll always be a line. There will always be, their constants are numbers. These are numbers. Will always be a line. For this reason, the equation y equals mx plus b is called a linear equation. Okay. Which of the following equations is a linear equation? They can only have one x and one y. The first one only has one x and one y. So this one is. This one has one y and one x, so it's fine. This one has one y and two x's. This is called a quadratic. It is not a linear function, a linear equation. All right. So sketch the graph of y equals negative 3/2 x plus 4. Now for this one, I told you I'm going to show you a way to do this and getting rid of the fraction. Okay. I use three numbers, not the same three numbers I used in the last ones. Only one is shared, and that's the 0. That's my ordered pair. I'm just going to label it like this. Here's my x, and here's y equals negative 3/2 x plus 4. All right. Now, I need two other numbers just to check myself. And I always, always, always use the denominator. I use the positive of the denominator and the negative of the denominator. So I'll show you why that works out really nice. Let me clean this up real quick. There we go. Y equals negative 3/2 times 2 plus 4. These reduce. You get 3, negative 3 plus 4 is 1. 2, 1. Okay. Let's do the next one. Y equals negative 3/2 times 0 plus 4. Anything times 0 is 0 plus 4, and so that is 4. 0, 4 is our next ordered pair. Last one, I'm going to use negative 2. So y equals negative 3/2 times negative 2 plus 4. The 2's reduce, and we get negative 1 up here. Negative 3 times negative 1 is 3, plus 4 is 7. So the last one is negative 2 and 7. Let's plot those three. Okay, so if you've got to this point, or you needed help getting to this point, pause the video, go plot these 3 points, and then come back to make sure that yours and mine are in the same place. So pause the video and come back. 2, 1. So I'm going to go to the right 2 and up 1. So it's positive. 1, 2, and 1. That's 2, 1. The next one is 0, 4. 0, and I'm going to go up to 4. And the last one is negative 2, 7. So 1, 2, and I'm going to go up to 7. All right. I'm great. Draw this real quick. And name your baby. So that's y equals negative 3/2 x plus 4. All right. That's it for that one. We only have one more to do. Okay. So the next one, I want you to attempt to do the entire thing yourself. So pause the video for this. Go do this one. And then come back. Unless you get stuck, and then come back to just get whatever you need to get unstuck, and then pause again. All right, because I'm going to work this from beginning to end. So make sure you give yourself a chance to do this, since I'm sitting right here to help you. All right, sketch the graph of y equals 1/3 x plus 3. Now is when you should pause the video and attempt to do this whole thing yourself, and then come back when you need help. So I'm going to set up a table where I've got my 3 terms for x. My equation's y equals 1/3 x plus 3. And then I just need my ordered pairs. Now, the x's I'm going to use are going to strictly be based on the denominator for 2 of them anyways. And so I'm going to use 3s, and that is the denominator. I'm going to use 0, and I'm going to use negative 3, which is just the opposite of the 3. So y equals, oh, do this again. All right, y equals 1/3 times 3 plus 3. 1/3 times 3, these reduce, and it's 1 plus 3, which is 4. So that's 3 and 4. All right, y equals 1/3 times 0 plus 3. 1/3 times 0, anything times 0 is 0. So that's just 0 plus 3, which is 3. And then the last one is y equals 1/3 times -3 plus 3. These reduce. That becomes a -1. 1 times -1 is -1 plus 3, and that is 2. Okay. Okay. So if you were with me up to this point, please pause the video and go plot these ordered pairs and see how your line turns out. Okay, and then if you're back, let's do this. So 3, 4, I'm going to go to the right 3 and up 4. 1, 2, 3. 1, 2, 3, 4. The next one is 0, 3. Right there. And the last one is -3, 2. 3, and then up 2. Looks a little bit wonky. -3, up 2, 0. Ah, no, 0, 3, I'm there. And then 3, 4. Yeah, it's there. I'm just trying to make sure, and maybe my dot's a little bit weird. Oh my gosh, I don't know how I can do this very easily. All right. I don't know, but my line is really weird. And this last one was -3, 2. And I'm just going to label my line real quick. And that is y equals 1/3 x plus 3. And you should do that with all your line. Okay. That's it. That's the last lecture for this semester. Have a great one. Hopefully stuck it out to the end with me, and I wish you the best. Take care. Let me know what questions you have from this.